Optics guys, what's up? It's Eckert here. It's Monday, April 6th. I only put one lesson up for you guys last week. Probably only gonna do one lesson this week. However, when I did office hours last week, no one joined, so I'm gonna do later office hours this week because I think after this lesson and previous stuff, there might be a lot of questions you guys have. I only have 2 days out of the week really that I'm kid free and I can devote 100% attention to you guys. So you got to utilize those hours. And if you don't, then you can email me, and I'm pretty good about getting right back to people about emailing. But when it comes to specific questions about certain things, if you don't talk to me in office hours, then you got to send me the question, the number of the question, the assignment, and do it through email. You guys can call me if you want. I'll put my my cell number up at the end of this if you want to call and talk about an assignment. But I would prefer you guys join the office hours and do it that way. There have been a lot of questions brought up, and I know there's a few kids that are hoping to graduate this year. And the question that was brought up is that there's a lot of people concerned about getting credit when they need credit to graduate. That goes back to what I've been talking about and what we've been talking about assignments, is that I know access has been an issue for individuals, but as long as you have Classroom, which you do, and you have internet access, which hopefully you should by now, the schools figured that out for you. These assignments that I post cannot hurt your grade. So get these assignments done. I will put a grade in for the grade book for you, and I'll give you credit. But understand that in order to pass the class, you need to know certain content. I'm doing the best I can to put that content out to you guys in this format. So you have to do whatever you can to get the credit, to do the assignments, and I'll give you credit. I will pass you. So pay attention, and let's get started with, this is gonna be my first lesson I do that's gonna be like a virtual instruction. This is somewhat new content, but not really. So I'm gonna share my screen so everyone can see what I'm doing. I'm gonna go into the questions that you're gonna be asked. So this is how I've been doing it for my health kids. I'm gonna do the same thing for the optics kids. It's just a little bit more difficult because optics materials are easier to teach when we have machines in front of us. When I can draw notes for you, when I have a whiteboard. I don't really have that on my computer. If I could find a way to get like a touch screen whiteboard, that would be sweet, but I don't have that right now. So in the meantime, we're gonna try it this way. So I will upload these and they'll be on Classroom. There is 2 pages of questions. As I go through my presentation here right now, I'm gonna flip back and forth between the questions and the presentation and sort of answer those as I go. It's your job to either pause the video of me talking and fill that in, or watch it and then go back and try and do it yourself. But then you'll have to go back to the video and find the information. But I will pause with what I'm doing and what I'm talking about and tell you, here's the answer to number 1. It's coming up, right? All right, so what we're talking about today, we are talking about tool selection. So if you remember, you generate a lens. You have this lens, it's created, you've made a curve on the surface. Well, now we have to bevel that lens. We have to pitch button it. You got to pitch button it by heating it up, right? Pouring green pitch into it. And then you take that green pitch button, you syrup it to a tool, and then you melt a blocking body onto it. Or you melt it onto the blocking body, if you will. And then once that's done, and I know not everyone has polished yet, but you get a polisher and you take it to a polishing spindle and you polish the optics, and it becomes what was once a translucent surface is now a transparent surface, right? And transparent, see-through, and that's what we want. And the whole process from when you block it to grinding with 20T, 12T grit using your divots is preparing it for polish, right? But when we talk about this tool selection, right? This is, we do this for you in the first manufacturing experience. So I'll say, hey, Nazir, grab the 216 concave blocking body, right? I have a tool in the oven. It's ready for you. I already know the radius. I tell you to pick it up and grab it, right? Well, when we do this another time, we have optics kids become more independent with selecting the tools and understanding why they pick the tool that they pick. So one of these lessons that we do after we manufacture optics is talk about tool selection, what tools you pick. And normally I draw notes in the notebooks and you copy along with me. Can't do that, but I have, I made a little PowerPoint presentation. So there's a concept, a bigger concept, and the company that I worked for last summer, Optimax, has really made their money on making really good optics really fast. And they use a concept of concentric circles and ensuring that their tool selection that they have and that they utilize allows them to do work more efficiently than anywhere else. Because of that tooling, you make better optics in a shorter amount of time. So the concept that they use is concentric circles. Now, what are concentric circles? If I flip over to your questions, number one, define concentric circles. Here you go. Concentric circles are circles that are different in size. So if you notice, I have 3 circles that I drew for you. They're all different in size, but they share one thing in common. They have the same center. So that same center point right there is shared by each circle, even though they have a different size. That's concentric circles. Circles that are different in size but share the same center. So that's what you'd write for number 1, right? Pause, type that in. Okay, so now, obviously, when we go to polish a lens, we need 3 things. So this is number 2. You need a blocking body, a lens that sticks to that blocking body, and a polisher. So there's 3 things you need. 2 of them are tools. The lens, the blocking body is an aluminum tool, and the polisher is an aluminum tool. Those are the 3 things. That's answer number 2. Now, as we all know, there's 2 types of lenses, right? I'm going to go back to my presentation, and we're going to talk about convex lenses first. So let's say I have a convex lens, and that convex lens needs to be blocked, and we need to polish it. Whenever I draw 3 circles, each circle represents a part. The middle circle, so the middle circle in size right now, or in diameter, if you will, always represents the lens itself. So I'm going to exit my presentation mode so I can do this and show you this. So I have 3 shapes to my right here. And for a convex lens, I'm going to choose this middle shape right here. And I'm going to show you what I'm going to do with it. I'm going to drag it over and I'm going to affix it to the middle circle. Does everyone see how I did that? I took this, I dragged it over, boom, and I locked it in right there. Notice the shape it just made. It has a convex curve, and then this semi-rectangular shape is the shape of a lens. If I were to hold a lens and you looked at it sideways, this is the shape that you would see. So right there, I've just shown you how that middle circle represents the actual lens that you're creating. Now, in order to machine that or polish that lens, we need to affix it to something. That's the blocking body. The shape down here. I'm going to take it and I'm going to drag it over into the smallest circle. And notice how that makes a mushroom shape, if you will. Anytime we hold a tool up that's convex, I always say, doesn't it kind of look like a mushroom? It's a mushroom shape. This is, for a convex lens, your blocking body, right? And then what do we use to attach your lens to the blocking body? Well, we use green pitch. So I'm going to take a green marker right here, and I'm going to color in green pitch to signify that lens being attached to my blocking body, right? So then the last thing you need is a polisher. Now, a blocking body, if you look on my presentation here, has a shorter radius, about 10 to 15 millimeters, and matches the curve type of the lens. So notice when I put the lens in here, it's a convex curve. This blocking body is a smaller circle. It fits inside the middle circle, right? So its radius is shorter. Should be somewhat of an easy concept. The radius is from the center to the edge, right? Shorter, smaller circle, shorter radius, fits inside the circle that represents the lens. About 10 to 15 millimeters is ideal for choosing a blocking body. So let's say I have a lens that has a 150 millimeter radius. You should be able to tell me, Mr. Eckert, the blocking body for that convex curve should be 140. It's 10 less than 150, right? Easy. And it should always match the curve type. The blocking body always matches the curve type. Whether it's convex or concave, always matches the curve type. Now, let's talk about the polisher. The polisher for a convex lens has a slightly larger radius. Oh, there's one line that we haven't done anything with, one circle we haven't done anything with. That's this biggest circle out here. It's a slightly larger radius than the lens, about 5 millimeters. Notice how the gap in between the circles, there's a bigger gap in between the first and second circle, and there's a smaller gap between the second circle and the biggest one, right? So I'm going to take this last shape over here and I'm going to drag it over to my circle and drop it in right there. Now the shape that was just created is the same shape as a concave polishing body. What do we put on a polishing body? We have green pitch on a blocking body. Well, on a polishing body, we use black pitch. So I'm going to draw a little squiggly line right here representing black pitch. Okay. And we have a very thin layer of black pitch, and black pitch combined with cerium oxide is what will gray out a lens or make it transparent. We call it graying out because it gets the gray color of the lens out, gets rid of it, becomes transparent. So right here for convex, the polisher, slightly larger radius, but it has an opposite curve. Remember, if you have a convex lens, you need a mate that's going to match to it and fit nicely on top. It has to have an opposite curve type. The polisher always has an opposite curve type, whether you're talking about convex or concave lenses. Now, I should be able to do this much quicker for concave. It's just we're going to flip some stuff. So let me go to the next slide. Concave lens tooling. The middle line is always the lens. Remember I said that, middle circle. The middle circle is always the lens. So I'm gonna take my middle shape right here and I'm gonna drag it over and drop it onto that middle circle. Ooh, notice how I made a lens in this one, but the curve goes inward. I took a shape, same shape over here, I flipped it and I had a convex lens, right? Well, I flipped that semi-rectangle over, I put it on that same second line, but because of the way I put it on, I now have a curve that goes inward, concave. The other two tools, you make the same way. So I'm gonna take and I'm gonna drop this. And if you want, and I suggest you draw this on your own, draw 3 circles, then draw that shape in the middle circle. Draw these shapes on the second and third circle, okay? Here's the difference. What was once the blocking body on a convex is now the polisher. What was once the polisher is now the blocking body, because the blocking body matches the curve type. So if you have a concave lens, you have to have a concave blocking body, right? So I'm going to take my green color and I'm going to actually put it right there. So let me undo that real quick. Sorry. I'm going to put green pitch where that would melt onto the blocking body. I'm now going to do black pitch to make my polisher. Make it a little thinner though. And here's my black pitch. I'm drawing on my polisher, right? So this is a concave setup. Now, blocking body is going to have a larger radius. Obviously, it's bigger, right? So this blocking body up here has a larger radius, but the same difference in size goes for blocking bodies. The blocking body is always going to be 10 to 15 millimeters in difference. But for a concave lens, the blocking body is going to be slightly larger. The polisher is going to be slightly shorter, but always by about 5 millimeters. So notice if I flip back to convex, the numbers and the difference in sizes are the same. Polisher's 5, blocking body's 10 to 15. If I go back to concave, blocking body's 10 to 15, polisher's 5, right? Where it's different is the blocking body for a concave is larger and the polisher is shorter. For a convex, the blocking body is shorter, but the polisher is larger. Now, I know your head might be spinning right now. It's okay. Because when we go to the assignment, you're going to start to understand when you answer some of these questions. So for part 2 of my questions, it says for the next few questions, fill in the blanks with the correct information from Mr. Eckert's presentation. Number 3 says, the blocking body should always blank the curve type of the lens. The blocking body, it should always match the curve type of the lens. So if you have a convex lens, your blocking body better be convex. If you have a concave lens, your blocking body should be concave. Number 4, the polisher should have the blank curve type of the lens. Remember, the polisher is going to meet and mate with the lens, if you will. So it needs to have the opposite curve type. So the polisher should have the opposite curve type of the lens. It's convex, it needs to have a concave polisher. It's concave, it needs to have a convex polisher. Number 5, for a convex lens, the blocking body will have a shorter radius by, blocking body is always 10 to 15 millimeters. And the polisher's gonna have a larger radius by 5 millimeters. Number 6, for a concave lens, the blocking body will have a larger radius, it's opposite, by 10 to 15 millimeters, and the polisher will have a shorter radius by about 5 millimeters. Hopefully everyone gets that now. So these fill in the blanks. The next part, you're going to be a little bit more independent with your work. You need to be able to tell me the two tools that you need based on the given lens radius. So I'm going to do the first one with you. I'm going to change my text to red. So if I have a 77 millimeter convex lens, what are the rules? Go back up top. The blocking body is going to match the curve, right? So right off the bat, I should know, oh, that's going to be convex. And the polisher always is opposite curve. So that's going to be concave. Let me make that red. Right? Whether it's concave or convex, those are always going to be, the blocking body is going to match it, the polisher is going to be opposite. So if I do this one for you, if the lens is concave, we know the blocking body needs to match and the polisher needs to be opposite curve type, right? The blocking body is always about 10 millimeters different, whereas the polisher is always about 5 millimeters different. But what you have to figure out is whether to add or subtract those numbers. So a blocking body and a convex, and I'll go back to the picture. Let's go to a convex here. The blocking body is right here. It's the bottom, because it has green pitch. Because it's smaller, the circle is smaller, it has to have a shorter radius, but it's always by about 10 millimeters. So if I go back here, the blocking body needs to be smaller by about 10 millimeters. Hopefully, everyone can do 77 minus 10. It's 67, right? So the blocking body for a 77 millimeter convex lens should be 67 millimeters convex. And the polisher has to fit above the lens to mate. So if I go back to my diagram again, the polisher's bigger, but the polisher's always bigger or smaller by 5. So if it's bigger, polisher's bigger for a convex, we're going to add 5 to 77, 82 millimeters. And it's concave. So now, for this next lens down here, the 89 concave, the blocking body's always 10 millimeters difference. If I go to the concave diagram, the blocking body attached with green pitch is the bigger circle. So we have to add 10 to that. Oh, wrong page. So we're going to add 10 to 89, 99 millimeter concave. Now the polisher is going to be different. We're going to subtract because it's the smallest circle, it has to fit inside. I'll prove it to you. Go back to the diagram. Polisher's the smallest circle, right? So we're going to subtract 5 from 89. 89 minus 5, 84 last time I checked. So I did the first two there for you. Now, you should be able to go through this chart and finish this. So this is your first virtual learning experience, if you will, in optics. You have to do parts 1 through 3. You're going to turn it in via the Google Doc, and there you go. All right. So office hours tomorrow are most likely going to be around either noon or 1 o'clock. I'll post those today. And if you have any questions about any of this, that would be the time. Set your alarm. Make sure you can get up by then. It's not early like last time. 12 o'clock is a good time. Everyone should be able to be awake by then. So, all right. Talk to you guys soon.